Thank you, moderator. Assalamualaikum warahmatullahi wabarakatuh. Thank you very much for the time given to me. Ladies and gentlemen, I will present my paper with a title, Stability Analysis of Two Predators and One Prey Population Model with Harvesting in Fisheries Management. By Didiharyono, Syamsuddin Toaha, Jeffry, Kusuma, and Kasbawati, with affiliations, Department of Mathematics, Hasanuddin University, Makassar, Indonesia, and Andi Djemma University, Palopo, Indonesia. This abstract is a summary of the contents of this paper, which contains the focus of the analysis, mathematical modeling, and result of numerical simulation. This study discussed the stability analysis of two predators and one prey population model in fishery management with constant harvesting effort. An example, at fishing population interaction model where butini fish as prey, which is endemic fish, while munjair fish and nila fish as predator format in mathematical modeling. Assumption of this model, prey comportment that follow the logistic growth model, competitive interactions between predator populations, and constant harvesting efforts occur in all three compartments, as shown at figure modeling scheme diagram. Based on the modeling scheme that then obtained mathematical modeling as shown fish equation by letting one F2 and L3, then fish equation is writing a second equation at this screen. From the second equation, four non-negative equilibrium points are obtained. TE1, TE2, TE3, and TE4. The equilibrium point for which the stability analysis is TE4 because a non-negative equilibrium point. So that based on the root harvest stability criteria, the equilibrium point TE4 is asymptotically stable. Next, based on TE4, determining the total revenue function or TE, total cost function or TC, and maximum profit or P on harvesting efforts. For determining TL, they use three equation and obtain it as shown for equation. For determining TC, they use fifth equation and then substituting TL in equation 4, and TC in equation 5 into the equation of maximum profit at S1 sixth equation. The maximum profit function is evaluated at the equilibrium point T4 to now the critical point of the profit function. The critical point of equation 6 is obtained by assuming the left side of equation 7 with a value equals to 0 as shown at this screen. The parameter value used in this study is adapted from the parameter value which is taken from a number of reference. Based on this parameter, these parameters are used to determine the equilibrium point of equation 2 or second equation, from which we have the positive equilibrium point T1 A4. The associated Jacobian matrix at this equilibrium point and obtained characteristic equation F lambda equals lambda etc. So that Ruth Harris stability criteria that equilibrium point T1 A4 is asymptotically stable. In order to simulate the profit function, we take the parameter value P1, P2, etc. So that the positive equilibrium point of equation 1 still depends on the parameter E1, E2, and E3. Then we have T2, F4. Therefore, obtaining a critical point E1, E2, and E3, it is easy to check that critical point maximize the profit function. They associate Jacobian matrix at this equilibrium point and obtaining characteristic equation F lambda equals lambda etc. So that Ruth Harris stability criteria that equilibrium point T3 F4 is asymptotically stable. Besides that, the given effort also maximize the profit function with value P max equals 5.19899,655. When this analysis is used by the government in terms of managing the renewable natural resource, the endemic fish population, especially for butini fish population, will not become extinct and will provide maximum and sustainable benefits. That figure 1, figure 2, and figure 3 show the dynamics of trajectories or solution curves against time t. The initial value by b1 equals 4.0, m0 equals 1.5, and m0 equals 1.5. This graph shows that the population will be stable at a certain time despite constant harvesting efforts occur. The conclusions, the growth rate of two predator and one prey population model with constant harvesting effort for the three population are investigated. The model actually has 4 non-negative equilibrium points. Since we just focus on analysis the sustainability of the population, the positive equilibrium point is only investigated and analyzes the existence and the stability. Without harvesting, the positive equilibrium point is asymptotically stable under a certain condition when the populations are harvested with suitable value of harvesting effort. The positive equilibrium exceeds and remains asymptotically stable. Thank you very much, moderator. Assalamualaikum warahmatullahi wabarakatuh.